All models are wrong, but some are useful. The faster you fail, the faster implementation speed is going to be, the faster you learn.
Yeah.
And I think people are so afraid to fail fast.
Yeah.
And I'm willing to fail fast, even though people might mock me for that. I did my bachelor thesis using MATLAB, and then in my master thesis I used Python.
Okay.
But still, to this day, MATLAB is my favorite language.
The Inspiring Computing podcast is where computing meets the real world. This podcast aims to trigger your curiosity by talking to proficient and advanced users of MATLAB, Python, and Julia, who use these tools to deepen their understanding of the world, simulate, explore trade-offs, and gain insights that help companies add more value. In addition to this, we will also be talking to product marketing, toolbox authors, package developers, and library maintainers to see what drives the development and what issues they're solving for others to benefit from.
Welcome, Jousef, to Inspiring Computing.
Yeah, very glad to be here at High Tech Campus.
I know, it's great. How about this? You and I both live in the same city.
Yeah, I've been living here for around 3 years. You, 6 years, around 6 years.
Yeah. So I've been working here at 6 years, but living in Eindhoven for about 15 now. But I wanted to talk to you because above and beyond being a podcaster, a YouTuber yourself, you've got your amazing company. I would like to kind of take the opportunity to meet the person behind asking all the questions, right? So I've seen you interview hundreds of people talking about CFD simulations. I've seen you talking about MATLAB, Python, open source, but you always do the questions and no one really knows the person behind those questions. So I'm really honored to have you on the show.
Thank you so much.
What's your superhero origin story? How did you go from wherever you started in Germany or curious boy to world famous podcaster?
Yeah. So thanks for the introduction. Really much appreciated. So I actually was born in Karlsruhe in Germany, studied there as well at KIT, focused primarily on structural mechanics in my bachelor's, then moved over to CFD, so computational fluid dynamics. So imagine you have a virtual wind tunnel in your computer. This is what CFD is all about in my master's, and then finished off with a thesis on AI. So geometric data generation and also identification using neural networks.
Okay.
And then I decided to work for a couple of startups.
Okay.
One in Munich for almost 6 years, and then for another AI startup in London for around 3 years. And then on the way, I decided to tap into the dark side of marketing, but also sales. And then I decided, I think this is a unique positioning where you have the engineering expertise, but also tap into the world of marketing. And combining those things is, I think, what is my competitive advantage. Now with Apex, a company that I founded almost 2 years ago. I think it's in December, it's going to be 2 years.
So, okay. So there's a lot of things I got to double click on. So let's start off with your company. We'll start with your company and then we'll work our way backwards about the podcasting. So Apex, tell me a little bit about this company. What do you actually do there, and how did you go from being a technical person to going to the dark side of sales and marketing?
So the initial idea was to do marketing for only tech and SaaS businesses, so software as a service business, because I was there in the startup world. I've seen how marketing is being done. It's very old school, I would say. So people are usually like, they're measuring KPIs, like how many blogs have you written? Like how many impressions do we get? This is a very narrow-minded view on how marketing should be done. And I feel there should be a different approach. So there's new things such as pay-per-click, so PPC, paid advertisement, and understanding the algorithm on Meta, TikTok, and all these other platforms, how these work. And that you, with inorganic growth, can actually create a flywheel. And what I mean by that is you, for example, put some amount of money, let's say 1,000 euros into paid advertisement. From those customers, you make more money, which you can then put back into the PPC machine. So it's kind of a self-accelerating flywheel.
But it seems like super logical, right? Is it people don't know in your area of expertise, like in the super technical domain? Because there are other areas which I think are like B2C. This is a well-known engine that people leverage, right?
I think this is a very good question. People got a little bit stuck in time because the thing is, they know about PPC, but maybe they're still running ads. They're just writing some random copy that they think works for the ideal customer profile and just launch it on LinkedIn, not knowing that LinkedIn is one of the worst platforms to actually run ads. So it depends on obviously who you target, but the cost per lead or the customer acquisition cost for a lead on LinkedIn is way too high. So you're spending so much on ads, you're literally burning money which are then also bad quality. Then when I tell customers, let's try Meta, and they're going to be like, why would we try Meta? There's only moms on Facebook, on Instagram, or only kids. And then they try it, and then the quality of leads is much better. This is only one parameter that we tweak. And then you have to tweak the copy itself. So how you write the text. Does it resonate with people? Do you deliver on an emotional basis? Also the visual. Is it a static image or is it a video? There's a lot of things that you have to tweak, but you also need to meet people who are in that space. So I'm continuously learning. I go to events in Germany and other places part of the world where I just learn about marketing and sales in general, like other new trends.
Yeah.
And if there are new trends, I should pick them up and integrate them into my own marketing.
But I'm a little bit curious because the way you introduced yourself, you kind of said that you were technical and studied computer fluid dynamics. I mean, so how did you go from the super technical person who understands maths and equations to then saying, actually, I want to go to marketing and sales? What triggered you to do that?
I still love engineering. I love MATLAB, I love Python, I love coding. But the thing is, I also love understanding humans. So the human psychology.
Yeah.
And this is where we tap into marketing and sales. So not manipulation, but more like understand human behavior. And can you understand human behavior by becoming better at marketing, but also simultaneously learning more about the human psychology. So I think if you are good at running ads, you must have a good amount of emotional intelligence to understand how people think, how they feel.
Does it work, yes or no?
Yes.
Or does this equation balance itself out or not?
Yeah.
But it's funny because I know you above, I think we crossed paths a few years ago, but I also seen your LinkedIn ads and you make lots of videos. So tell me a little bit about that idea of making videos. What triggered you to make these videos?
I was studying mechanical engineering, as I said, and during my studies, I felt like a lot of professors know what they were talking about, but they didn't communicate it in a way where someone normal, who's not a genius, would understand what they actually mean. This was kind of that sparked the idea of like, okay, let me just create videos and explain like how the momentum equation is being derived so that normal people understand it. And this is how the idea of like deriving the Navier-Stokes equation was born. All these videos that have like a couple of 100,000 views on YouTube. This is how the idea started. And then I just started with podcasting. I think I asked on Reddit, the first guy, hey, I'm going to start a podcast. Who wants to be on the show? And then there were the guys from Atlantic Sea Colony. It's my first podcast. And they were like, yeah, we're open to talk about like we want to colonize the ocean.
Yeah.
And this was my first podcast. Horrible editing skills if you go back to my first. But I think I like being a generalist. So knowing a lot about different kinds of topics. So engineering, sales, marketing, coding. And I feel like I'm more like a generalist. So like more like a T-shaped personality. I know a lot about engineering, but I know a lot about other different topics like coding, sales, marketing, all that kind of stuff. But I'm trying to be more like a pie-shaped personality. So the Greek sign pi, where you are like, you know a lot about marketing, sales, and a lot of other topics as well. I like that. That challenges me.
Tell me a little bit more about this podcast. So you created the podcast. Was it a YouTube channel at the beginning? Or was it first a podcast and then you turned into a YouTube?
So I initially started with a podcast and then I had to put it on Spotify because people were asking for it. I think I released 10 episodes and then people were asking, is it available on Spotify? I said, nope. So I was going to Anchor. Back in the days it was called Anchor. I think Spotify bought them.
Yeah.
So I had to distribute it to Spotify, Apple Podcasts, Google Podcasts. And this is how I just grew my podcast. But the initial idea was to pick people's brains to learn from them. Because I feel a lot of people are very narrow-minded in the sense of they think they have the ultimate truth.
Yeah.
Their worldview is the only thing that exists and there's nothing else besides it. But me interviewing a lot of smart people, I've realized that I know nothing. I basically know nothing, which also humbles you in a way because you understand there's so much to learn.
Yeah.
So it humbles you, but it also gives you perspective of what you don't know.
Right. But your podcast, so the name of the podcast is?
Engineered Mind.
How did you come up with that name?
Yeah, it was just a stupid name that I came up with because I feel like we want to engineer our mind. I'm an engineer myself and I want to engineer my mind in such a way that I can tweak parameters and become smart in that area. So I just called it Engineered Mind.
Nice. And you've got, over 100 episodes. You've been doing this a while.
Yeah.
And the different topics that you do there, do you have like specific categories that you hunt down? So I know there's a lot of CFD, you've got a lot of MATLAB, but do you have a mental model of what are good topics for your podcast?
As long as it helps people.
Yeah.
I love interviewing people in that area. So I have Engineered Mind as one podcast, but I also have the Apex podcast now, which is solely about marketing and sales. So I want to get thought leaders from the space here so I can grow my knowledge in marketing and sales, but also build friendships and relationships with them. But also in the Engineered Mind, it's more like, okay, CFD, FA, nice topic, cool. But at some point, after 100 episodes, you've talked enough about these topics, I feel. So I also had people talking about psychology, burning out, the path to becoming a great engineer. Like things that help people, things that I would wish I would had when I was a student. And I think people always come to my podcast because they feel they can get something out of it. If it's solely for promotional purposes, nobody cares. I think people nowadays have become so smart. This is something Google coined the term zeroth moment of truth, where it's like people don't go and buy immediately. They research very well of what they want to buy, who they want to buy from. And this is, I think, over the last 5 years, I've built my reputation in this space.
Yeah.
People know me, but it's very easy to ruin my reputation with something like I'm going to sell a scammy course, I'm going to sell an altcoin, whatever. So yeah.
Well, that's the journey as you become more famous and well-known, right? You have to be cautious. People latch on to who you are as an individual. and your content is really nice. People say, oh, Jousef knows all these cool people, therefore he must be an awesome person. But actually in your podcast, you don't do a lot of talking. You do a lot more listening, which is really good, and I appreciate it. But of all the episodes you've done, is there one particular episode or story that you think like, wow, this really stuck in my mind?
Good question. I don't have a favorite, to be honest, because I feel every guest is special. Everybody has their own story, and the way they see the world, it's always a little bit different than how I see it. And that made me more open-minded.
Yeah.
I think the learning that I can open my mind and realize that I don't know everything is also a big benefit for me.
Right.
This was the biggest learning for me.
Right. So you're on Inspiring Computing, right? So part of what we do here is to kind of inspire people to leverage the computation where the real world is using technical computing in some shape or form. So tell me, is there anything here that you kind of, when you were studying, that you lacked, that now you interview a few people that say, oh, I wish back in the day, one of my teachers told me this particular case. Is there one specific example that you'd care to share?
I think nothing comes to mind like immediately, but I feel like, failing fast.
Oh.
It's probably not a particular episode where I got that from, but realizing failing fast. Because everything I do, or probably you do as well, Gareth, is the faster you fail, the faster implementation speed is going to be, the faster you learn.
Yeah.
And I think people are so afraid to fail fast.
Yeah.
And I'm willing to fail fast, even though people might mock me for it. Look, the video quality is shit, or his editing skills are bad. But the thing is, just because you do it, I've started 5 years ago, and now my editing skills are really good. Like I edit videos very fast, and this is a very good skill to have. So I don't need to hire someone externally to edit my videos.
Right.
And people can't bullshit me.
Yeah.
So when I hire an editor, they're going to be, that took me 3 hours. Nope, that took you 20 minutes. So being a generalist also opens up ways from the business side of things to understand, like, is someone bullshitting you?
Right.
And I think this is a very good skill to have.
Well, it's funny the way you said, like, so like failing fast, right? That actually crosses into multiple domains. And it's ironic because it crosses into sales, marketing, right? So you make a pitch, it didn't work, you make it a little bit better. Marketing, there's the A/B testing, you try something, there's a feedback loop. But it also applies on the engineering side. So the concept of a simulation is exactly that, right?
Yeah.
So when you simulate things, you're trying to simulate as many different possibilities to deepen your understanding. And that's effectively what the whole CFD world is all about, right? You have a set of assumptions, you simulate, does it match, yes or no, and you fail fast. So it's funny that you say that because your whole life seems to be about that.
Yeah, but if you think about it, if you go to the gym, for example, or do any kind of exercise, it's also failing fast or learning how to improve that exercise to get a bigger return on invest.
Right.
So everything in life is about failing to some extent.
And it's okay to fail, right?
It's okay. Yeah, but I think people demonize, especially in the internet, if you fail, then you're a loser. But honestly, I couldn't care less because I've taken that path. I know also people in my family who have said, like, why are you doing this podcast? After like 10 episodes, they're going to be like, you don't earn any money with YouTube. I said, it's not about the money. It's about like just being able to improve my communication skills or maybe becoming a better podcaster, better editor. I want to learn about these camera settings, like white balance and all that kind of stuff. It just improves lives overall.
I think it's very inspirational. So it's very good. But I also noticed on some of your podcasts and your YouTube channels, you also talk a lot with the MathWorks ecosystem, so MATLAB. So where did you first get exposed to MATLAB? How does MATLAB fit into this whole story? Was this back at university or I'm curious.
Yeah, it was in university. I think semester number 4 or 5 maybe.
Yeah.
But I definitely wrote my bachelor thesis using MATLAB. So I was having, I'm not sure you call them, but it's like from an engine. So an engine part, I had it under a microscope and we were measuring the roughness, the surface roughness of that so under a microscope. And that has then been imported to Abacus, which is a structural mechanics solver from the Sol system. This has then I was writing code to automatically generate a report with all the roughness parameters.
Okay.
So the engineer would get a roughness parameter report, surface report with all the roughness parameters and the simulation results from that simulation being done in Abacus. So kind of like an API thing that you code up with or hook up with Abacus. And for me, that was fascinating. The funniest thing is I was procrastinating. In every thesis I wrote, I was procrastinating. Bachelor and master thesis. But then the last 2 weeks of the thesis, I somehow got the weirdest ideas. Okay, you can code it up this way. This is why, like, I think working under pressure is also probably a learning I got from doing this YouTube thing and just studying in general. But yeah, going back to MATLAB, got exposed because of modeling and simulation. We had courses there in uni. Did my bachelor thesis using MATLAB, and then in my master thesis, I used Python.
Okay.
But still, to this day, MATLAB is my favorite language.
So to zoom back into where you started with the MATLAB side of things, the surface roughness, why is that so important? So for those who never studied mechanical engineering, so you say you're looking at a surface underneath the microscope, can you explain, like, Why is that even important?
For example, let's say you have a company that tests different types of oil. So you have different viscosities. So how liquid or non-liquid something is. For example, honey is less, less liquid, I would say, than water, for example. I think so people can easier imagine what I'm saying. So you want to understand from a surface roughness point of view, if, for example, the surface holds more oil or less oil, and if that in turn impacts, for example, the engine efficiency or how the engine operates. So this would be one connection you could make, and there's 1,000 different connections you can make. So for example, higher roughness, then you have the component holding more oil.
Yeah.
So is that good or is that bad? Well, it depends on the scenario, right? And then you can kind of do some studies if that's actually beneficial or less beneficial for the engine.
Right. So it's funny you say that, because in your podcast, you interview people from a wide variety of applications. So when it comes to computational fluid dynamics, a whole area of mathematics behind it. But actually, it's always surprising that you can go from super small to super big applications. And most people don't even think about, okay, so what is the impact of a surface in an engine? Isn't the engine the most engineered piece of machinery we've ever had? We've had 100 years of engineering manpower going into this, and yet there's still areas of innovation to explore.
Yeah, definitely. And there's also AI companies that still explore to this day how to optimize combustion engines, depending on what operating point they're at. So you still could, with AI, like optimize, for example, surface maps. You have surface maps on what RPM and what temperature and so on, like what's the optimal operating point. And even to this day, engineers having hundreds of years of knowledge about combustion engines, they still haven't figured it out completely. Now we have AI coming in that helps engineers to find the optimal configuration for specific operating conditions, different weather conditions, because an engine is not just an engine, it also depends on the air intake, temperature, on so many different parameters.
Right.
People wouldn't think about this. But now we have AI kind of a second mind that we engineers have.
Right. So it's interesting you bring up AI. So you've got a bit of background in MATLAB, you've got a bit of background in Python. I'm kind of curious, and you say you're doing CFD, but MATLAB is not known for being the tool for CFD, right? So can you maybe at a high level talk me through your experiences in the MathWorks ecosystem, open source ecosystem, and how that plays into the CFD, if it's coupled, decoupled? I'm curious to hear your thoughts on this.
I've never coupled the different programming languages to solve a specific problem. But what I've noticed is I've done solved one CFD problem in my master's on an Orr-Sommerfeld equation, where you solve a specific fluid physics phenomena.
Yeah.
This was a 1D/2D problem, but if it goes to 3D problems, it becomes quite complicated because MATLAB can become quite slow.
Yeah.
Then it might make sense to move over to languages like C++. Then there's a whole other story of how to allocate memory and, but you don't have to think about that in MATLAB. This is why I love MATLAB so much, because as a beginner, is what you write is usually what you get. You speak how you like defining variables, so you don't have to think about allocating memory most of the time, especially as a beginner. And then in Python, it's the same thing. You could also solve much more complicated problems as you would do in MATLAB compared to MATLAB, but I can't generalize it now. Probably there's some ways to also hook up C++ with MATLAB. I think there is a way, but I've never used it myself. I know one guy, he also wrote his master thesis in parallel with me. He had performance issues solving a dynamic system.
Okay, yeah.
It was about engineering mechanics, and he had to optimize it because he was running the simulation for 7 days. I was like, there has to be an easier way. So he found out that you can hook up like C++ code with, or integrate it
with
MATLAB, and then he solved it in like 1 day.
Yeah. So
it's like, this was one case, but I've never coupled them. But I think there's probably ways to intelligently do this.
So given that you've also kind of got this broad overview of, and you're a generalist, so you see MATLAB, you see Python, you have the other simulation tools, what would you tell someone who's about to learn, go into engineering, right? So you're a mechanical engineer. Would you say, hey, go for MATLAB, use Simulink, learn the SimScape language, it's really powerful? Or do you say, hey, the AI is playing a more predominant role, and maybe MathWorks is not as well known for AI component, maybe Python is more of a way people iterate to? Do you have an opinion of how to help someone who's getting started in their career?
I'm very biased. I would tell them start with MATLAB because it's the easiest to start, but also Python is very easy to start. So maybe it really depends on what you're trying to solve, right? If you're an engineering student, MATLAB may make more sense, especially because they have a lot of canonical cases or a big documentation of engineering problems that they solved.
Yeah.
So the documentation is awesome.
Yeah.
I want to solve a physics-informed neural network, for example. There's already documentation on how to do this, but in a similar manner, Python has the same thing. So you could also solve it in Python. It's really a matter of preference. I think you should try both, see what fits your style and
fail fast.
Yeah, fail fast, exactly. So if you don't like Python, go to MATLAB. If you don't like MATLAB, go to Python. Maybe use both combined. It also works. But I know with AI coming up, I don't think there's the necessity to learn languages like C++, is my opinion.
Yeah.
It really depends, obviously, on what you're trying to solve.
Right.
So I want to be careful there making any
Well, right. So I also agree with you. It really depends what you're trying to solve, but people sometimes get religious about a language,
Yeah.
right? It should be A or B. And I kind of like the way you phrased it. It's like, well, try both and make up your own mind. And who knows, maybe you could actually work with them together. You never
Exactly,
know, right?
yes.
But I'm also kind of curious on going back to the CFD. I'm not so into that domain myself. So I'm an electrical engineer, so I know about it, but I haven't done any simulations. Is this something that you say that there's still plenty of work and it's a good place for people to invest? Or is this kind of something like, yeah, all the problems with CFD have kind of already tackled, so anyone going down that route will only have minute improvements on any existing system?
This is a good question. I would say the CFD market is very saturated. A lot of people want to get into CFD and do CFD consulting. It's a very competitive field, so you have to be a very good engineer and very good CFD engineer.
Yeah.
And understand fluid mechanics and how the meshing works. So how do you tessellate a surface, for example, to make sure the results are accurate, to really represent how the fluid is actually behaving in the real world?
Yeah.
It's because it's only a model
Mm.
at the end of the day. And a model is only as good as the person sitting in front of the PC is like defining the model to look like. And also it's always garbage in equals garbage out. So if you're a bad CFD engineer, your results will probably be garbage as well, most of the time. I think it's very saturated, going back to your question, but I think you should give it a try. Take one course on CFD, see if you like it, because some people really don't like it because of its complexity.
Yeah.
So we haven't solved everything. And I think that we still need very good CFD engineers,
Right.
because there's so many problems out there that need to be solved using CFD.
But are there like a couple of misconceptions, common pitfalls that you see people going on? Or maybe yourself when you started on this journey back in the university days?
You're thinking it's easy. You just click a button in the software and it's going to solve it for you. That's not the case. So especially how you define the boundary conditions. So for example, where's the inlet, where's the outlet? What assumptions do you make about the real component in the real world versus the computer model? And there's this dichotomy between, okay, I could fuck it up here in my model in the PC versus this model actually behaves much differently in the real world than I would have assumed. So that you have to be very careful on what boundary conditions you put into your simulation.
And have you been caught off guard with that idea of like you modeled it and you thought, okay, this is really good. And then in reality, you were confronted with I was way off, or like, oh dear, I didn't realize that assumption was so important. Is there an example?
Yeah, not in that way, but probably when you're at uni, you have this kind of click by click instructions from the course instructor, whoever. And then you click something and you don't know, okay, it says nonlinear geometry. Why do I even click that? Yeah, just click it. It's going to do something behind the scenes, and then you don't actually know what it's going to do from a structural mechanic point of view now. But the same goes with CFD. People just, okay, click this, then you click this, and then you suddenly have colorful pictures.
And everyone's happy about it. Okay,
everyone's happy, yeah. Colors for directors, but you don't know why it's actually looking like that.
Yeah.
So you have to be also very critical and think about your own results. You have to think if that actually makes physical sense. So you also need a strong physical foundation. Knowledge about if you tap into CFD or FEA.
Yeah. So it's funny you say the critical sense. I often think that criticality in anyone who's creating a model, it's easy to get results of some shape or form, but then testing and validating that is actually a whole art by itself to get it right.
Yeah. And I've talked to someone who owns a CFD company. I've recently interviewed him, and he said the hardest thing is finding an engineer who solves things end to end, from problem specification, identification, to solving it all the way to the results, to report generation. Because a lot of people just want to solve it and be done with it.
Yeah, because that's how their mind works, right?
Exactly. As nowadays, especially with the effect of TikTokification, people's minds work like a goldfish. They swipe and then, okay, attention is gone. And I think the same goes with engineers or like any person out there. The attention span is just drastically declining.
Right.
And it's funny that he confirmed it. Like he's looking for a lot of people that he interviewed is like, okay, can you solve this problem? And then they stop 50% along the way and they're just, what about the other 50%?
Oh, that was someone else's job.
You can't do that. I think it's very important now for people listening to this to really stick to something. And I think it's very easy to outcompete people if you stick to something 100% for an extended period of time.
Yeah.
This is why I've grown to over 160K followers on LinkedIn. People always say, how did you do it? There's a strategy behind it, but the thing is you have to be consistent.
Like keep going at
regular.
it.
Same as goes with the gym. If you go to the gym, if you're not consistent,
you don't build up your muscles. So I think this is really great. You're a super inspiring kind of guy. So if people want to reach out to you, what is the right way to reach out to you?
My website, jousefmurad.com. I'm currently rebuilding the website to make it look more modern. And then my agency is called theapexconsulting.com.
Okay.
And then obviously on LinkedIn, you'll find me.
Awesome. This is great. Is there anything that I didn't ask you, Jousef, that you want to get in there? Is there something you want to talk about?
Just in general, to stay humble.
Yeah.
Because there's so much that you don't know.
Yeah.
And I feel I've met so many people in my life who are not humble, but I've seen them go up very quickly and fall very quickly. Because just be always kind to people I can't answer everybody. I know I have a lot of unread messages on LinkedIn, but I can't solve everybody's homework.
That's it for today's episode. I hope you enjoyed the conversation and found it valuable. If you did, please consider sharing this episode with your friends and family or anyone who might benefit from it. Also, I'd love to hear your thoughts, so take a moment to leave a review and let me know what you think. And if you haven't already, don't forget to give us a rating. It really helps us reach more people and bring you even more amazing content. Thanks for tuning in, and I'll catch you on the next episode.